Good morning, good afternoon, or good evening, whatever time you're watching this educational video about frictional forces. In most of physics related problem, friction forces are always neglected or taken for granted. But this time we will let frictional forces as our main characters in today's video. When we talk about frictional forces, these forces exist when an object moves along the surface. These forces acted on an object in parallel manner, opposing the motion of the object. And then gravity this time is positive. Let's agree that it's positive because we are focusing on how strong would be the normal force, not where it needs to be. So we're not dealing with the direction of the gravity this time. So we're not making it negative, but we will have positive because we want to focus on the value or magnitude of our normal force. Okay, and the first type of friction that I will introduce this moment is the static friction, and this is our symbol F and then subscript S. That's static friction. Okay. And static friction keeps an object at rest. That's the goal, or I mean, that's the function of static friction. It it wants that the object will be at rest. It will not move. Okay, and it adjusts up to a maximum value before it will eventually move. And then it always equals to the applied force, not until it reaches the maximum static frictional force or the FS max or the static force maximum. Okay, and it's like it keeps in equilibrium. Whatever the applied force, that's the same static friction. Okay, because they are just equal. Okay, it always equal to the applied force, not until it reached the maximum threshold. Okay, and that's all about static friction. If you will encounter or if you push something heavy, the very first instant moment, you cannot really push the object. There's something that there's something that makes it stay there, and that's the static friction for some short period of time. And then um, with like more newtons to be applied, this object will eventually move. And that moment that if the object does not move, static friction is there because it keeps an object at rest. That's the purpose of static friction. And static friction will act as the centripetal force if an object will round a curvature. Instead of the car that will, slide off, or let's say, um, um, run or speed up in a straight line in a curvature, because of the static friction, it will maintain the circular arc or the circular motion of the car. So the static friction will act as our FC or the centripetal force in our previous video. And always remember this equation here. Fs should be less than or equal to the Fs maximum in order for it to keep the object at rest. More than that, okay, more than the value of the Fs max, static friction will no longer serves its function to keep the object at rest. It will eventually move. So here are the equations involved in our static friction. We have the Fs maximum. All you have to do is to multiply the coefficient static friction. That's the symbol mu sub s. And we will multiply by our Fn, or the normal force. Okay? And coefficient of static friction, we will know it later. Then if you will be asked to get the Fn, or the normal force, all you have to do is to derive your formula from this Fs max, coefficient friction, um, times the normal force. You will derive the formula if you want to get the Fn. So here it is. Fn is equivalent to your Fs max divided by the coefficient of friction. It's just derived from this equation. Another thing, don't forget in our previous discussion that Fn, the normal force, is always equal to the mg, or the weight force, if there's no acceleration. Okay? And then your Fs, your static friction, is equivalent to the mu static, or the coefficient friction, multiplied by Fn. Fn, once again, is mass times gravity. All right. Let's talk about coefficient of static friction. This is the symbol. The best, or the good definition of a coefficient of friction, is that the measure of stickiness between two surfaces. The magnitude of the coefficient of static friction varies. It depends upon the pair material, and it's dimensionless, meaning no units. So you will encounter a certain magnitude with no units in the problem. That's the coefficient static friction, and they are uh, less magnitude, or let's say the amount of it is lesser. Okay. And then if ever that you have a larger coefficient, the harder it is to move. Obviously speaking, if the coefficient, that's the stickiness between the two resting object, if it's larger in magnitude, of course you cannot really move it easily. And it tells us the maximum resisting force before it will eventually move. And like what I have said, it's constant, right? It's constant, and it depends upon the material pair. For example, rubber on a dry concrete, this is the range of the coefficient of the static friction. And if ever the rubber on a wet concrete, the same surface, but this time there's a substance that makes the coefficient static friction lesser. Okay. And then you have steel on a dry steel. This is the static friction, becomes higher. And then wood on wood, it's lesser than steel on dry steel. It's constant. That's the range of the coefficient static friction. Our North Star here, Fs, only exists if it is equal to the applied force. Okay. Fs, the current static friction, exists only if it is equal to the applied force. If it's not, of course, forces are balanced. I mean, unbalanced, because applied force is no longer equivalent to our Fs, or static friction. There's a motion in it. And remember, static friction, it keeps the object at rest, not moving. It will only lose its power once the applied force is greater than the maximum static friction force. Okay. For example, no force applied, of course, no static friction, and then no net force. Remember, if there will be no net force, if the net force is zero, balance, the forces are balanced, and if the forces are balanced, there's no motion. Okay. No motion. Okay. I'm sorry for my penmanship this time, as always, right? Because I don't have my like a good a good thing or a good gadget that will uh make my presentation better. Okay. And going back to the table, if a 10 Newton force is applied, we have also 10 Newton static friction force. Remember, your Fs is always equal to the Fs, but it's in opposite direction. So if it's positive here, it's better to put negative in these values, meaning it's just the direction. Okay. Remember negative here. Don't be afraid of this sign because it talks about the direction. It's going to the um, left side of our um, Cartesian plane. So if ever a 15 Newton force is applied to the right because it's positive, now the opposing static frictional friction is negative 15. So when you will subtract positive 15 and negative 15, you will have 0. If it's 0, forces are balanced, no motion. And this is now the last, I guess this is the threshold, 19.6 Newton, and then minus 19.6 Newton. That's a static friction. It's still 0, so no motion. But now it's greater than what we call the Fx max, by the way. This is now the Fx maximum static friction that an object or between two objects and the surface, object and the surface, it will only um, the maximum value or magnitude of our Fs, it's only 19.6. More than that, the object will now move. And if you notice, our Fs now becomes 0 because the object is moving. Okay, the object is moving. There is a greater Newton being applied, and you have to subtract it. 19.8 minus 0, that's 19.8. So there is now a net force, meaning the object is moving. In this part of our table, if you notice, the net force is nothing here. It's 0, so meaning the object is not moving. If you notice, applied force is equal to the static friction. Static friction exists only if it's equal to the applied force. If it's not, if it exceeds the maximum static friction force or the Fs max, like this is greater than the Fs max. So there is no, there is motion now in this case. Okay. Now let's have the next slide. We have an object here represented by a rectangular object, and then that is the coefficient static friction there between the object and the surface. And the vector that goes below is the mg, that's the weight force, and it is always balances with normal force. And then if ever we have an applied force in that direction, the opposing or the counteracting force is the static force. Okay, just like that. We have a word problem here. A 20-kilogram wooden crate sits on a flat wooden floor. So there's an interaction, a direct interaction between wooden crate and wooden floor, and you try to push it horizontally with a force of 60 Newton, provided that the coefficient of static friction between wood and wood is 0.5. Let's figure out whether the crate will move And if not, let's calculate the actual static friction force acting on a crate. Okay. In our problem, these are our given variables. We have the mass of 20 kilogram. The applied force is 16 newtons. We have, of course, gravity 9.8 meter per second squared, and the coefficient of friction. No unit because it's dimensionless. Okay. Now, let's have it first to figure out if the crate moves and how. So we are going to find the maximum static friction force in order for us to judge or to say that a crate can be moved if there is a 60 Newton force being applied to the crate. Okay? The formula of our Fs max is this. Fs max is equal to negative coefficient of static friction multiplied by the Fn. It's negative because it's opposing to the applied force direction. Okay, negative there is going to the left side of our Cartesian grid. Okay, and Fn, always remember Fn is equal to the mass times gravity. So we can rewrite the formula. 0 0.5, that's the value of our coefficient static friction, and we have mg. So our mass is 20. You will just substitute it here in our m variable and in the gravity, and it's positive. Okay. Then you will multiply all these factors. It will generate, or it will give us a product of negative 98 Newton. And it's negative because it's going to the left, opposing to the applied force direction. So this is the maximum Newton that this object can hold as it keeps the object at rest. Okay, this is the maximum static friction, and 16 Newton is being applied and attempting to move the crate. Will it move? Provided that this is the maximum static friction, 98 newtons, and you just applied 60 newtons, so obviously it will not move. Since 60 Newton is lesser than the max static friction force of 98 Newton. So only more than 98 Newtons applied force can be able to move the crate. And 60 is lesser than that, so there's no motion. If not, there's a follow-up question here. If not, let's calculate the actual static friction force acting on a crate. Actually, there's no need to calculate because as we discussed a while ago in the previous slides, your static friction is equivalent to your force applied. It exists if force applied is equivalent to the static friction. So if ever the applied force is 60, so our actual static friction is also negative 60. It's just the opposite. The direction is opposite to the positive 60 Newton applied force. And it will result to zero net force, no motion. Okay. Another problem, a sled is resting on a horizontal patch of snow and the coefficient of static friction is 0.350. The sled and its rider have a total mass of 38 kilogram. And what's the magnitude or the value of the maximum horizontal force, the applied force the maximum. Okay. And then the force or the maximum force that can be applied before the sled will move. Okay. And it's a it it's an easy problem. Okay. And the given variables, we have 38 kilogram as the mass, 9.8 gravity, and we have the coefficient of static friction, 0.315. And let's determine the maximum horizontal force. Remember that your applied force is equivalent to your Fs max or your static friction. But this time it's the maximum applied force. So if it's the maximum applied force before the object will move, so it is also equal to the Fs max. That's pretty simple. Okay, now the maximum applied force is equivalent to um, negative coefficient static friction and then Fn. Remember, this is the formula of F F Fs max. It's just the coefficient of static friction times the normal force. Let's substitute our given variables to this equation. So we can also, we can rewrite Fn as mg. That's still the same. Fn is equal to mg. And we will input our given here. So we have the coefficient of static friction. We have 38, the mass of the sled and the rider. And we have 9.8 gravity. And it will give us a product of negative 130.34. Again, negative here is direction. Okay. So it is not a lesser magnitude or lesser number, but it's just the direction. Negative means going to the left, opposing the applied force. So our applied force maximum is the same to our Fs max. More than that, let's say 130.35, more than the maximum static friction, the object will move, but it's just a little movement. And sometimes we will never be feeling it, or we cannot really notice it that it moves a little. But if it's more than 130.34, the object will begin to move. So it is the maximum force applied, and it's equivalent to the static friction on its maximum range. So it's zero net force, so no motion. Okay, so in this case, we have this diagram, or like free body diagram. It's a 6 kilos or a kilo object, and you have a coefficient of static friction, which is 0.4, and we need to find the static friction maximum. Okay, and if this is the formula, Fs max is equal to negative coefficient static friction times Fn. Fn can be written as mg. It's the equivalent equation. And you will just have to substitute all the given variables. We have 0.4 as our coefficient of static friction. We have 6 mass of the object and 9.8 gravity. And therefore, the static friction maximum is 23.52 Newton. Lesser than that, the object, lesser than 23.52 or equal to 23.52, the object is not moving. But more than 23.52, 23.53, for example, it's more than the threshold, so it will move unnoticeably. Okay, we cannot notice it because it's just a little. But if it's more than 23, like 13 Newton above the maximum static friction, so static friction will no longer serve its purpose. So another force is present when the object begins to move. Okay, we will discuss that one in our next video. What if we applied 23 Newton to this 6 kilo object with a coefficient of 0.4? Will it move? Okay, so 23 is lesser than 23.52, so it will not gonna move. The static friction will gonna be negative 23 newtons. Okay, it's just the same. It's lesser than the maximum, so this will not move.